Here, let us see how this reciprocating compressor works. So here this crankshaft is rotated by the motor, and when this piston moves downwards, here the pressure will go down, and that will be lesser than the atmospheric pressure here. Then what happens automatically, this is a poppet valve, this will get opened and the fluid will flow into the compressor or the system. Now when it moves upwards, what happens automatically, this valve will get closed and the other valve, the outlet valve, is on the other side. And when the pressure is more than the pressure here which is connected to the collecting tank, automatically this will get opened and the fluid here, compressed fluid here, will be moving or passing to the collecting tank. That is how it works. And you can see there is single acting compressor as well as double acting compressor. In single acting compressor, there will be one discharge per one rotation of the crankshaft, and here the fluid will be on this side also. And there, when one complete cycle of this crankshaft completes, or after one rotation, here there will be two discharges. Okay, so that is the double acting compressor. And here the multi-stage compressor is there. Here you can see on the figure, here there is one compressor and in between there is an intercooler, and this is the other compressor. So already this will compress the air to some specific pressure, and after that here it will be further compressed by the second compressor, and this is the two-stage compressor, and it will get to it will be connected to the collecting tank. We will see how this compressor works by using the indicated diagram. Here you can see DA or ABCD, this figure, and here this is the assumptions that we make. One is polytropic process, PV raised to N is equal to C, and this is adiabatic or reversible process, internally reversible adiabatic process, PV raised to gamma is equal to C, where gamma is adiabatic constant. And you can see the isothermal process where PV is equal to constant. These all relations we have already studied in our thermodynamics class. And you can see here 1 to 2 double dash, that is your polytropic process, and 1 to 2 is the adiabatic process, and 1 to 2 dash, that is happening when we assume that the process is isothermal. Now the work done by this piston on the fluid is equivalent to this area. So you can see the lesser area is when we assume the process to be isothermal, and in between that adiabatic and isothermal, it will be polytropic process. And when it happens in the adiabatic manner, then the work that needed to compress the fluid is more. And we will see the cycle in the in this indicated diagram. This D2A, that is our induction stroke, 1 to 2, and 2 to 3. What happens here, this here the temperature T1 is there and pressure is P1 there. Now on the next slide it is given there the induction stroke. So D2A, this is D2A, where the intake or suction stroke, or you can call it as induction stroke. Now the temperature as well as pressure is the same here. Okay, and here you can see the volume is increased from 0 to V1. Now what happens 1 to 2, here the temperature is T1 as well as pressure is P1, and it is increased to P2 or T2. That is your compression stroke A to B here. And this is according to the polytropic law, PV raised to N is equal to constant. And see the third one, here what happens when it is compressed, here the delivery valve gets opened, and that fluid, compressed fluid, goes into the collecting tank, and it reaches to this, it happens at constant pressure, and the volume comes to 0 here. And again the suction, in the suction stroke, the fluid is sucked in and again compressed, and it is fed to the tank, collecting tank. That is happening here. Now you can see that when there is excess temperature during compression, when it is compressed, temperature will get increased. Now the surrounding air of the compressor that will be at a lower temperature, and what happens, the excess temperature here will lose to the air. Now there will be the friction also. Even if we neglect the internal friction, the index, this index gamma will be lesser than 1.4. Okay, the which is in the adiabatic index. If n is equal to gamma is equal to 1.4, if it is not less than 1.4, the area under the curve is the biggest, which is internally reversible adiabatic process, which is called as entropy isentropic process or constant entropy process. Now what is internally reversible adiabatic process? Adiabatic process means the heat transfer will not take place through the boundary of the system. So whenever there is an increase in heat here, it will not lose. But when it is loosed, or whatever increase in heat is there, whatever increase in heat here is lost to the surroundings, then the process will be happening in isothermal process, isothermal condition. Then you can see here, when it happens as an isothermal process, the work done will be, the work we need to compress the fluid will be lesser or minimum, or you can say optimum. And when it happens in as polytropic process, pv raised to n is equal to c, when gamma is less than 1.4, then there is an intermediate amount of work that is needed to compress the fluid. But when it is internally reversible adiabatic process, it consumes most of the work. Now you can see that when this 1.4 is reduced to 1, then the process is PV is equal to constant, which is equivalent to the isothermal process. So that you have to understand here from the indicated diagram.